Okay, we we're going to talk about operating system. Right now, the first thing we're going to talk about is operating system. What is operating system? Uh, Operating system is the a software that controls the computer's basic functions. Okay, and handles interaction between software and the hardware. See, operating system is user, okay, with hardware. User working with hardware. What are the hardwares? You know, hardware is everything you see in a computer. You talk about then after hardware, you talk about software. What is software? Hardware is like mouse, it's like keyboard, motherboard, everything, all the power supply, video cards, printer, speaker, joystick, headphones, everything, these are USBs, these are hardware. The software is a program that is designed for doing some certain thing, okay? It's designed to do some certain things, like play games or do mathematics and these kind of things. Okay, the operating system manages the computer resources. When you are using text editor and at the same time you want to talk to, you want to send email, see, the operating system manage that, talk to the different devices like keyboard to see what what action they must take, and so allocating memory to those application programs, CPU also, using those memory, all the devices, hardware devices, these kind of things all need memory. So operating system does that for you. Doing everything that makes things, the computer runs smoothly. Yeah. So we have kernel. Kernel is also a system software. The operating system, we talk about kernel. It's a system software a part of operating system. It is a part of operating system, and provide interface between application and hardware. See kernel here, application and hardware, computer hardware, we talked about it. Application program, all kind of program application could be, everything that either built in is different. There's some programs built into the computer and do things for you. So kernel, what does kernel do? Management, doing management of file system, device control, everything, that actually is the core of component of a computer operating system. So it's a bridge between application and hardware. So managing system resources, memories, CPU, device driver, all this. What are these? Yeah, or cache memory. So different operating system. We have Windows operating system. We have Mac operating system. We have Linux. These kind of things. So it is. Let's talk about the devices. See, the device driver. What is device driver? Yeah, it is a specialized software and act as a bridge between operating system and a specific hardware. Operating system with a device driver talk with the device driver. And allowing the computer communicate with the device. The device. If you have the device driver, you want to communicate with the, you have keyboard. Okay, you have the device driver for keyboard, for printer also, and everything else. They have these devices have the device driver. Okay, so the computer communicates with this device, and there is also device controller. What is device controller? Is an interface between a device and device driver. Then between a device and device driver, there is a called device controller. Okay, and responsible for moving data between the peripheral devices, and that which controls its local buffer storage. Operating system so have a device driver and a device controller. Okay. There are some other programs like Bootstrap. What does Bootstrap does? Is the initial code. It runs when the computer started. It's powered on. That Bootstrap program does that and load the operating system to this computer system. And also, what is happened resides. This resides in the read-only memory. Volatile is non-volatile. Okay. And also BIOS, basic input-output system, that you can manage the communication between operating system and the hardware. So that's by BIOS. So that the one of the things, and it's a process. What is process? Process also is a that programs. Any programs, it will be consist of some threads. Those process means execution of an application. Is a process in the system, and also operating system manages threads and process. Okay, and let's see. So we talked about these, and then cache memory, storing data so that for the future request it can be saved much faster, can be retrieved and served faster. And these are other things that you should. What is thread also? A single sequence of instruction that can manage by the operating system scheduling multiple tasks with those process, a single sequential flow of activity being executed in a process. Okay. Basic unit of CPU processor utilization. Okay. So, and the number of the threads that the CPU can execute also, you will find out, you will read it. And so let's solve some of the problems that we have in the operating system. And also, talk about the scheduling. Scheduling, when you execute multiple threads, from the different applications, you have different threads. Scheduling is that the execution of multiple threads in a single CPU. Okay. Now we are gonna talk about some of the points here. Okay. Let's add this addition of the binary numbers. Okay. See, binaries, if they give you a decimal number, you learn how to, well, you learn it in networking, but I'm going to mention a little bit. See, you have 1, 2, 4, 8, 16, 32, 64, 128, and if more larger number, all these things, it's going to be 255, because 128, 64, 32. See, if give you a number that is 254, what happens? Here you have 0, the rest of them is 1. Means 128 plus this is going to be 254. So if they give you 54, what's going to be? Yeah, we can use 128, these are 0, and 32, we can use 32 minus 55, and 16 is going to be 48, up to 54 is going to be 6. Okay, this is then 4, 2 plus, it's going to be 54. Okay, that was how converted the binary to numbers. And then you say 54 in a binary number. Okay. What about if they give you this 15 dead? This is hexadecimal. Okay, what is going to be the number? You say, okay, write it here. 1, 2, 4, 8, 16. 1, 5. 1 is going to be this one, like in a 4 bits, like about 4 bits. It's going to be 1. It's going to be like this. This is 1, and then we have 5. Is what? 0, 4 plus 1 is going to be 5, and then D. What is going to be D? D, remember 1, 2, 3, 1 to 9, and then 10 was A, 11, B was 11, C 12, D 13, A, B, C, D, E 14, F 15. Okay? Now we say D. What is D? D is 13. What is 13? It's going to be 8 plus 4, 12, and this is going to be 13. E. Okay, what is E? E is 14. So 8 plus 12 is 12 plus 2 is 14. And all these A is 10. So 8, 2 is going to be 10. And then D is the same as. So we write it here. We write it like this. 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0. That is going to be 15 dead converted to binaries. Sometimes the question, what decimal does the 8-bit binary number? Okay. What decimal does 8-bit binary number of so before that, let's talk about the adding or subtracting a number. Like for example, you have 10 here. 1, 2, 4, 8. Oh, okay. And then 10 is going to be 8 plus 2. This is 0, 0. And then 8. 8 is going to be 1, 0, 0, 0. Okay. And you add it. 0, 0 is going to be 0. 0, 1 is going to be 1. Almost 0, 0 is going to be 0, and 0, 0 is going to be 0. See, if you add this to the carryover is 1. It's going to go come here. So this is, it should be 18. See? 8, see? 16 plus 2, this is 16, okay? 16, and this is 2, is going to be 18. So this is the add of this. What happened is, or if you talk about minus, You know, in general, in plus of binary. Okay, what do you do? If is 0, 0 is going to be 0. Is 1 plus 0 is going to be 1. And 0, 1 is going to be 1. Okay. And if you want to convert some binary number, okay, so if you want to give you 8 bits binary number, and they say they interpret it what decimal does 8-bit number. Okay, if we use this one, the binary number is 1, 0, 1, 0, 0. If you add this together, okay, it's going to be 128, 1, 2, 4, 128. 128 plus 32 plus 16 plus 4 is going to be 1, 16, 8, 4. We add these together. Okay, just a second. I lost that here. So it's one we are gonna use computer. You go to Window and open a calculator, and then you come to 3 lines there. Say programmer. Then if you put number in decimal, they give you binary. If you put binary, it's gonna say 1, 0, 1, 1, 0, 1, 0, 0. It's going to be 116. Okay. It's no. I made a mistake somewhere. Okay, clear. Ten, 11. 10, 11. 0, 100. It decimal. This is 180. This is 180. Okay? $180, write the index there. And if you want to, this is the, you call it interpreted as an assigned number. Interpreted A. Interpreted as assigned number. We give you a binary number in 8-bit. 1, 2, 3, 4, 5, 6, 7, 8-bit. The Binary number given as a signed number. Signed number. It's going to be 180. Now, if you add -1, 10, 11, 0, 1, 0, 0, -1, what is it? -1, what is that? It means if this is, if you say 1 from 0, you have to give 1 here, eliminate this one, and 2, and then 1 here, and then 0 minus 1 is 1 here, and it's going to be like this, okay? It's going to be like this, and then if you flip it, it's going to be, on a computer using 2's complement, okay? When you use it complement, you reverse this one, so this is going to be 0, 1, 0, 0, 1, 1, 0, 0. Okay, this is 2's complement. And so it's 2's complement, and that one a signed number. There are many other questions that we talk about it. So let's talk about what is the biggest positive number one can represent in 5 bits memory. 5 bits. 2's 5 bits. That is going to be. The formula for that is going to be 2 to the power n minus 1 minus 1. If in 5 bits, 2's complement, 2 to the power of 5 minus 1 minus 1 is going to be 2 to the power of 4 minus 1. 2 to the power 4 is going to be 16, so it's going to be 16 minus 1 is going to be 15. So that's that. If it's in 8 bits, like the largest positive number in 8 bits, n is going to be n. 2, 8 minus 1 minus 1, 2 to the power of 7 minus 1 is going to be 128 minus 1 is going to be 127. Okay. So see, in your computer, just if there is a time, when you go to at the bottom of your computer here, at the window, you click, you see the calculator, okay, and then the calculator say